Hello children, in continuation with the third lesson, force and pressure. Today we are taking the new point, that is the pressure. In this we will see, yesterday we seen the inertia and its types, activity inside we seen, activities we seen, and after that we seen the types of inertia. Today we will see the pressure. So what is pressure? So pressure, you must have observed the tire of two-wheelers. Okay, all we are observing this. So four-wheelers getting pressurized and air filling machines has a pressure indicating dials. Okay, whenever we are filling the air inside the tire, that time one machine is there, it shows the indication how much air pressure is there inside that tire. Okay, so a digital meter is showing the digital reading of pressure. The machine feels the pressure to a certain value. Okay, up to a certain value that machine is there, it feels the air inside it. So you are aware that force has to be applied for filling air. Okay, so if you are filling, in olden days one pump is there, and by using that pump what happens, we are filling the air inside that bicycle's tire. So what we are doing, we are taking that handle upside, piston is there inside it, and we are taking it upside and we pressurize it down. So what happens, due to this what happens, air enter inside the tire. Okay, so you are aware about the force has to be applied filling air. So to fill air, what we have to need, most important, we have to apply the force on it, and then what happens, the air is enter inside the tire of a bicycle. Now with the hand pump, by applying force, air pressure is increased. Okay, if we apply the force, what happens, air pressure is increased and then the air is pushed into the tire. Okay, what we are doing, if that pump, that activity you seen inside it, you will understand that when we are pulling that piston upside, at that time what happen, air enter inside the pump, and that air when you are pulling it down, then what happens, it enter inside the inside the tire. Means what happens, the pressure, we are applying the pressure on that pump and it air enter inside the tire. Okay, so this is happen when we are filling the air inside the tire or tube. Are the force and pressure are related? These force and pressures are related? Yes. When we are applying pressure and force, they are related to each other. Now next activity, that third activity, take some sharp pointed nails, okay, and push them into a wooden plank. If we are taking the pointed nails, okay, suppose this is our nail, okay, and if this is the plank, if we want to push it, we have to hammer it, then what, we are applying the pressure from this side. Okay, we are applying the pressure from this side of a nail, and what happens, and this pointed end is there, it slowly enters inside the plank, and what happen, after some time it fix inside that plank. So what they told you, now take a wooden plank of hammering on their heads. Now take the nail and hold with the heads on the plank and hammer down the pointed end. Okay, so when pressing the drawing pins into the drawing pin, they get into the board easily. Okay, by applying force using the thumb, one can push the pins into the board. On the contrary, while pressing the ordinary pins into the board with a thumb, our thumb may be hurt. So what they told you here, suppose this is our drawing board. Okay, this is our drawing board, and if you want to, this is the drawing board. Okay, and this is your pin that we have to press. So by applying force on this top of this nail, what happens, we can easily, what happens, this nail is what happen, it enters inside that drawing board and we can press and fix it in that position. Okay, so when pressing a drawing pins into the drawing board, so when we are pressing a drawing board, they get into the board easily. So we are applying force from this point, so what happens, they get pressing inside the drawing board, they get into the board easily. So by applying a force using a thumb, one can push the pins into the board. So by applying, we can pressing from upside, applying the force, what happens, we can push the pins into the board. On the contrary, while pressing the drawing ordinary pins into the board with a thumb may hurt. Okay, and this structure is there. Okay, this structure helps us to easily press this pin into the drawing board. In ordinary pin we are using, then what happens, it may be just our thumb may get hurt. Okay, now the next point is, what does the simple experiment tells? So the nail easily penetrates into the wooden from its pointed end. Okay, when it easily enters, when the pointed end is there, we are taking towards the what, board. That time what happens, we can enter it very easily. From this you will notice that when a force is applied on the head of the nail, it is easy to hammer into the plank. So when we are applying force or a hammer from this point, it easily goes inside this. Okay, now use your brain powers question. So from this what we are understanding, one more thing is that if less is the area is less, more is pressure we are applying on it. Okay, but if this pointed head we are taking towards the board, and this head we are taking towards the plank, and we are hammer from this point, then what happens, it will not penetrate inside the plank. And why this? Because the area is more, and due to this what happens, pressure is less. And in this situation here area is less area, and when we are hammering on it, more pressure is applied on a small point, and what happened, it easily penetrates inside the that plank. So it is easy to cut vegetables, fruits with a sharp knife. A blunt knife doesn't work it. And why does this happens? Okay, so if we are looking how are our forks are there in home, so these types of forks are there in our home, and this part is there, it is very sharp. It is very sharp. When it is sharp, then easily what happens, we can cut the vegetables. Any vegetables is there, if you cut it, it will cut very easily. But if it blunt means what happens, the blunt means, suppose this is very sharp point, this is the sharp point. By this what happens, we can easily cut it, but the area is more, this part's area is more, this part cutting part is there, this part's area is more, so it is what, it is blunt. Okay, and this part is what, it is sharp. If it is sharp, then what happens, its area is less, this area is less, and because of that less area, what happens, whatever pressure we are applying, that pressure what happens, it applies on that vegetable and it cuts it easily. But blunt is there, area is more, so what happens, the pressure what happens, it distribute, and the cutting may be hard or it may be difficult. Okay, so just now I told you the example of the nail. Same way, if we are taking the pointed end towards the plank, then what happens, easily penetrates, but the head if you are taking towards this, it is impossible to penetrate this nail into this plank. Okay, so from this what we are understanding, the definition of force, that is force, the relation between force and pressure. A force exerted, what they told you, a force exerted perpendicularly on unit area is called as a pressure. What they told you, a force exerted perpendicularly on unit area is pressure. Suppose we will take example of the nail only. So this is our nail, and this is the head, and this is the plank, this part is the plank. So when what they told you, force exerted perpendicular, so this is the nail, its perpendicular position is this. Okay, this is its horizontal position, this is perpendicular position. When we are hammering from this side, okay, when we hammer from here continuously, then what happens, slowly this nail is there, enter inside the plank. So this is the unit area, this is the unit area, I will show you different color. This is the unit area. On that area we are applying the force from perpendicularly, and what happens, this is called as a pressure. At that place, at blue color shown, no, at that place what happened, pressure develops due to the force applying on this nail. Okay, so what is the relation between them? The force is perpendicular to the unit area, then it is called as a pressure. Now pressure, what is the formula for pressure? Pressure is equal to force upon force upon area on which the force is applied. What is pressure? Pressure means force upon area on which the force is applied. Suppose this is nail. Again I am giving the same example always for better understanding. Suppose this is a nail and we are applying force from here, means by hammering, okay, and at that place what I told you, pressure develops. So this is the area, okay. So pressure's formula is that force upon area on which force is applied. So that area, how much is the area? If area is less, more pressure is applied, means it is an inverse proportion in between the pressure and the area, okay. Less is the area, more is the pressure, okay, and more is the area, less is the more is the area, pressure is what? More, something is wrong. Less is the area, more pressure we can apply, and force is directly proportional, means pressure, how much force you are applying, that much pressure is developed on that area, okay. Now we will see what is the unit of pressure. Unit of pressure we are finding by using the formula only. So what is the pressure's formula? The pressure is equal to force upon area. So tell me pressure, okay. So force we are always measuring in the Newton. Force we are measuring in the Newton. Now these things are new for you, so keep in your mind, because it is helpful in the next standard. So force we are always measuring in the Newton, and we are showing it with the capital N, okay. And area we are measuring, area of square whatever is it, we are using the unit, that is the meter square. So Newton upon meter square. And this only we are writing in this way, Newton per meter square, and it is the unit of pressure, okay. So and this is the unit we are using in SI system, okay. We studied it in last standard, that is SI system and the CGS system. So in SI system, pressure is, unit of pressure is Newton per meter square. How we derive? That is force unit is Newton, area's unit is meter per square. So divide is here, so divide sign we put it here. So N upon meter square is equal to Newton per meter square, okay. Now this is our which unit? The SI unit, and this is only called as a Pascal, okay. Newton per meter square, what? Newton per meter square means only Pascal. It is called as a Pascal. It is a name of a scientist, okay. On honor of his work, the name is given to this unit, okay. So this is the Pascal, and it is in short form we are writing it as a PA for Pascal, okay. So that is Newton per meter square means only Pascal, and Pascal we are writing as a PA. In atmospheric science, the unit of pressure is bar. So 1 bar is equal to 10 raised to 5 Pascal. 10 raised to 5 means on 1 5 zeros, okay. So and pressure is a scalar quantity, means on it direction is we are not taking in account, so that's why it is called as a scalar quantity. Presently we are considering only the force acting on the area. What? In present we are considering the only force acting on the area in a direction perpendicular to it, okay. So next point is the, just I told you that next example inside, if area increases, pressure decreases or reduces the same force. If the area decreases, the pressure increases on the same force. Force same if we are applying, but area is less, then what happens? The pressure increases. Area is less, decreases, pressure increase. That is the relation, okay. And area increases, pressure reduces, means only decreases. In between them the inverse variation is there. So how we are writing this? So pressure is inversely proportional to area, okay. Pressure is inversely proportional to area. So if pressure area, what happen? Increases, pressure decreases, and area decreases, pressure area increases, pressure decreases, and area decreases, pressure increases. So in this way we find the relation between the area and the pressure. For example, due to natural adaptation, bottom surface of the camel's feet is broad, okay. Its feet is, what happens? Its feet is broad. Now Hence the camel's weight is exerted on a large area. Okay, so he whole the weight of this camel is exerted on a large area. The pressure on the sand is reduces, and due to this what happens, pressure on the sand is reduces, and due to this reason what happens, the camel can easily walk in the sandy region. That is why camel's feet do not penetrate into the sand and it becomes easy to walk. What they told you, see here, that only relation is there in between the force and pressure, and due to this reason only what happens, the camel can walk easily on the desert region. Okay, as his feet are broad, okay, its feet are broad, the all the weight of the camel is exerted on that feet. Okay, and due to this what happens, this feet is broad, so what happens, when it is walking in the sand, that time what happens, the pressure which is on the legs, it forms, it becomes less or reduces, and due to this what happens, it can, when the legs are not penetrated deep inside the sand, and what happens, it can walk easily in the sandy region. Okay, now next, pressure on solids. Okay, and for this they gave you activity, and this next part of the is the pressure on solid. So air pressure is exerted on the object kept in the air. Okay, you just kept anything, we are also in the air, so on our body also the air pressure is applied. Okay, anything you take on it, air pressure is there. When weight is kept on solid, so when weight is kept on solid, if you see these pictures downsides, you will notice that these books are there, these books are on this plank, and plank is on the two blocks are there, on it is located. So this pressure depends upon the value of weight, how much is the weight on it, so the pressure depends on the weight and contact between the in between them. So for that we will see this activity. If you observe this, you will notice that here it is, this is the plank and this is two blocks are there, and this plank is easily, we can kept it here, and it is straight, horizontally straight, it is located on these two blocks. Now in the second picture, this picture inside, here four books are kept on the plank, on the plank separately. Okay, so what happens, and in third picture if you see, all these four books are kept one above the other on a one place. So due to this what happens, if you see here, the area which is comes in on contact with this plank is, this is the area, red line I shown, no? So what happens here, area increases, and at this location only this much weight is same on both the planks inside, but here area is more. In first picture area is more, and in first picture more area is used for keeping the what books, but in second picture less area is used for to keep this plank. And due to this what happens, if you observe this plank, you will notice that this plank is there, it bends little bit in between where the books are kept. Why this happens? Because less the area, more pressure is applied. So due to this what happens, the more pressure is applied on it due to this weight, and that's why the plank is bent in the between. But in the first picture the equal weight is there, but it is distributed in some places, so more area we used, and that's why what happens, the plank is straight horizontally. Okay, so based in this way we can say that more is the area, less is pressure is applied, and less is the area, more pressure is applied on this. Okay, so afterwards here some user when brain powers questions are there. You must see the vegetable vendor carrying the basket on her head. She keeps a twisted piece of cloth on her head below the basket. Okay, suppose this is a basket, this is basket, and that lady is there, she is keeping one cotton's ring like structure on it. And why she is keeping this type of ring on it? So the reason behind it, whatever is there, you have to find out. We will discuss it on in our next lecture. And we cannot stand on one place a long time. We can't stand on one place for a long time, but we can sleep more than 8 hours on one place. Why is this so? This reason also you have to find out. Okay, and for skying the on sky, why the long flat skies are used? Means when you are that flying skying, at that time these types of broad planks we are using, and here shoes are there, and on it shoes, what happens, you are putting your legs. Why? And you have to find out, use your brain powers, questions are there, you have to find out the reasons of these three questions that then today then we will discuss this question in on our next lecture. Okay, so we will stop here till next lecture. Okay, thank you.